Right. So we'll talk about Amazon EC2 cost optimization today. We look to understand what containers are. Amazon has container services. Um, those we'll look at. Then we'll move on to AWS Lambda, which is serverless computing. Finally, we will end our class with a discussion or looking at the one of the compute service, and now all of these are compute service, we know, right? It's called Elastic Beanstalk, Amazon or AWS Elastic Beanstalk, which is for web applications, right? So let's start with EC2 cost optimization. Now, you may have already seen that Amazon offers a various EC2 pricing models, right? Or various ways of getting EC2 or reserving, on demand, all those things in AWS cloud, right? The one we use in lab or development and testing here, we use the AWS free tier ones, and they are on-demand instances, right? If you use on-demand instances, so like whenever you need, you will get an EC2 or instance. You would be paying by an hour, right? There's no long-term commitments for on-demand instances. Another model is something called dedicated host, where you are actually getting a full physical server on which EC2, the EC2 instance you will be using resides, right? So full physical computer, you can kind of you can reserve, or you can pay for that, right? Full physical server with EC2 capacity, fully dedicated for your use or our use. Others are dedicated instances. Now, dedicated host, we say we can get dedicated host as well. Similarly, you can get dedicated instances as well, right? Instances that run in a VPC on hardware that is dedicated to a single customer. So some of these things we can dedicate, we can pay and kind of fully reserved, although they have used reserved term for other things for us. We can reserve instances as well. So there are three paying model here: full, partial, or no upfront payment for instances you reserve. If you go back to third week, we did an exercise, we did an activity in the lab, third or fourth week, where you calculated using Amazon Cost Explorer. You calculated for a particular scenario, right? If we are using on-demand or reserve instances, how much it would cost, right? So we have kind of looked at these things before as well. Now, it also, with reserve instances, you get discount on hourly charge for that particular instances because you have reserved. So Amazon has can administer can do better administration of their own resources, right? You can reserve for 1 year or 3-year term depending on your use. There's another scheduled reserved instances. So you purchase a capacity reservation that is always available on a recurring schedule you specify, and which is offered for 1-year term, right? The final ones are spot instances. These instances run as long as they are available and your bid is above the spot instance price. So you have this market price, right? And you have bid it, you put a bid, right? If your bid exceeds the current market price, whatever that market price for instance at that point of time is, you will get this instance, right? They can be interrupted. We have to worry about that. They can be interrupted by AWS within 2-minute notifications, right? Interruption option could be terminated, stopped, or hibernated, right? Prices obviously are significantly less compared to on-demand instances because AWS can in a way take those instances back, right? So you could choose this kind of instances when you have flexibility, when your application should run or can run, right? There's per second billing also available for on-demand instances. Usually, as you can see, it's pay by hour or it's 1 year, or 3-year term reserve. But per second billing is also available for on-demand, reserved, and spot instances that run either Amazon Linux or Ubuntu. Not available for um, the EC2s, which runs Windows, or if you install Windows, right? Pricing model benefits, you can see on-demand instances will incur low cost and flexibility. So whenever you need it, you'll take it, and if you don't need it, you just release it, or you delete it, terminate it, right? Or simply stop it if you plan it to use in the future. Remember, when you stop an instance, if it is not running, it won't incur charges, right? We don't have to delete always, or in Amazon terms, terminate always. Spot instances, for that, if you have large scale dynamic workload, you could probably consider spot instances. They are better suited for them. Reserved instances, which basically, if you have, you know, kind of constant or predictable workload, right? Predictable workload, then you could, know that these kind of instances, this kind of storage things I need for a period of time. So you can reserve those instances for that period of time. Dedicated hosts, it will be, you can save money on licensing cost with dedicated host. It also helps meet compliance and regulatory requirements. Now, if we see use cases, which is pretty much tied with benefits, you can see if you have spiky workloads. So sometimes your traffic goes down, up, down, up, down. It keeps happening like that. Then you will go for on-demand instances, right? It's a short-term idea. If you know long-term traffic pattern, you probably go for reserved instances, isn't it? So short-term, spiky, or unpredictable workloads. If you have that, go for on-demand instances. You can use for application development, these kind of on-demand instances, like for learning we are using, right? Or for testing, right? Spot instances, if you have time insensitive workloads, right? It's not time sensitive, it's insensitive to time, then you can go for spot instances, right? Applications with flexible start and end times. They are only feasible at very low compute prices, right? Users with urgent computing needs for large amount of additional capacity also can consider spot instances. The other other model is reserve instances. You can use that for steady state or predictable usage workloads, right? If you have a pattern, you can predict. If you have a constant pattern, then it's easy. Or if you are predictable, you can predict your traffic, then you can simply reserve instances to use, right? Obviously, you're going to use it for applications that are that require reserve capacity, including disaster recovery and other things. Finally, you have dedicated hosts, right? Here you can bring your own license BIOL, right? So you don't have to, if you have a Windows and enterprise usually have license bought, you can use that license, so you don't have to get Windows from AWS or other softwares. Similarly, for other softwares, you can use same license, right? It is compliant with the legal terms or regularity restrictions. You can use uses, you can track uses, license. Also, you can track a control instance placement. You have full control for instance placement as well. So if you have dedicated host, you can place your instances in that particular dedicate the host which is dedicated to you. There are 4 pillars, as AWS says, for cost optimization, which is right size. You choose right size. You consider to increase elasticity, right? You will look for optimal pricing model. and you will try and optimize storage choices as well. So let's look at each of them, right? Right size. Now, we would provision, we would configure, or we would plan instances to match our need, right? Based on what? How much CPU we would need for instances, memory storage, or network throughput, right? So it's not like just the idea is not to select whatever is available, but first work out what we need in terms of these resources, and then go and find what kind of instances actually is meeting our need, right? We can use cloud watch metrics to help us, right? How idle are instances? Like for example, one you are already in business and 1 month is running, right? But at the month end, you can see where those instances were actually used, the application running on those instances are used, where they're idle or where they're full busy. If you are full busy, you probably would like to increase. If they are not, they keep sitting idle there. What time? Those kind of things, right? Then based on those decisions, we can always downsize. Amazon recommends us to choose first right size, which meets our need, and then go for reserve. Reserve, you can simply reserve those instances for long term according to your need. Increase elasticity, the second pillar. We can, as I said, we can stop or hibernate Amazon EBS backed instances that are not actively in use. So if you stop, it won't cost us, right? Example, non-production environment or test instances. When we have non-production environment, non-production where we are developing or testing, after the test is over or production is over for a day, for example, we don't want it to be running, isn't it? Right? We can simply stop it and go, right? The other aspect is we can use automatic scaling to match the needs based on users as well. So if it is not used, if you have 10, you have chosen, let's say 10 instances, right? Based on cloud watch metrics or other decisions, you can scale it to 15, or if it is not needed, we can, after 10, the 10 could be reduced to 5, right? We can have automated or time-based elasticity, again, based on our need. Optimal pricing model. So we should leverage the right pricing model for our use case. Obviously, considering our users patterns, we can optimize and combine purchase types. For example, use on-demand instances and spot instances for variable workloads, but go for reserve instances for predictable workloads, right? We can also consider something called serverless solution, AWS Lambda, which is another compute service which we are going to look, which we are going to study in a short while. So in today's class, right? We should also look at optimizing storage choices, so reducing cost while maintaining storage performance and availability, right? We can resize EBS volumes. Remember, in the lab, you may have done a small exercise. That's just for one, EBS volume, which was attached to your EC2, right? If you remember, we could easily, in that lab, probably you decreased, right? But if you can decrease, you can always increase as well based on your need, right? So we can optimize those choices as well. For for EBS volume types, right? We could also consider, can we simply meet the required performance for our application with less expensive type? For example, right? The EBS throughput optimized HDD hard drive, which is ST1, right? It's costs, less high, much less, basically, typically cost half as much as the default SSD, which is generally, there are SSD, GP2, GP3 as well. So which, we should look at, do we really need GP2 or GP3? Can we can our application run on SD1 still having a acceptable performance, those kind of things, right? We should also look at deleting snapshots if you have collected the snapshot that are no longer needed. So basically, it's all, we should design, think about it, put elaborated thought before making or choosing any of these resources for cost optimization. Identify the most appropriate destination for a specific type of data. For example, does the application need the instance to reside on EBS? Right? There are Amazon S3 storage option available with lifecycle policy that can reduce cost. Now, the storage module is next. So we are going to look at next week. Now, in that, when we talk about storage options, we'll see, so non-frequent data where we can put, frequent data where you can put. So obviously non-frequent storage will be much cheaper than the frequently accessed data which we store somewhere. So there is Amazon Glacier and other things which we gonna look at, right? So continuously measure, monitor, and improve, right? Cost optimization is not just one-time process. It is an ongoing process. So the AWS recommendation are define and enforce cost allocation tagging. If you remember, in second class or second week, we were talking about billing management thing, cost and billing management thing, right? So we went, we could go there and tag, create a group or tag to know who is using what and how much who is using. So in your organization, we have multiple users, obviously, right? So what they, you just configure and how much they are using, what kind of things they are using, can they be downgraded, can they be, upgraded? Is there a need? Something like that, right? Using cost, how much a month cost incurred, we can revisit and always based on that make decisions. We can tag, for example, we can tag as students. So all students uses you can see, and this tutors and other things, right? You can tag. Tagging is basically name grouping together similar kind of users. In this case, define metrics, set targets, and review them regularly. Encourage teams to architect for cost, right? So when other teams are making these things, we should always encourage, let's go for cost optimization, something like that. Think about cost optimization before start working or using Amazon resources, right? It's always also a good idea to give this responsibility to an individual or a team who continuously is monitoring this cost optimization in a periodic manner, right? So the key takeaways from EC2 cost optimizations are, as you can see, it includes on-demand instances, reserved instances, spot instances, and dedicated instances. So we have category and dedicated hosts. And so we have categories from choose from as per our need. So there is no hard and fast rule, but depending on our need as an organization or an application we are running, we can do that, right? If we choose spot instances, we should remember that it can be interrupted with 2-minute notification. So if you are running an application which has to run, for example, web server for continuous period of time, this may not be a good choice, right? Spot instances are there to save cost. So if you have that kind of workload, that kind of application, which doesn't need to run 24/7, which doesn't need to have highest reliability and availability, then we can use spot instances as well. There are 4 pillars for cost optimization. Cost optimization, an ongoing process, right? Ongoing periodic process, continuous process. We should think about right size of EC2 based on CPU, memory, and other factors. We have many other AWS services, for example, CloudWatch, to see and help us make decision. AWS Cost Explorer is another, another tool which we can use to choose right size according to the cost and need, right? We should always thrive to increase elasticity, to scale up or down using automatic scaling. That's the last module, but we have to mention here. We'll see how automatically we can scale our EC2s in probably last or second last module, right? We should go for optimal price modeling and always look to optimize storage choices. Any question on EC2 cost optimization? Okay. Next, we are going to look at container services. Now, container services also comes under compute services category in AWS, right? So, what is container, right? Containers are a method of operating system virtualization. What is a VM? What is virtual machine? Now, virtual machine, you can, with similar kind of definition if you want to give, virtual machines are a method, VMs are a method of hardware virtualization, your machine virtualization, right? Containers, on the other hand, are a method of operating system virtualization. Your container would contain, right, your application, obviously, or development if you're developing that application, and whatever that application needs, any dependencies, configuration, and the host OS hooks into host OS, not the entire operating system because they are virtualizing. Whatever they need, that only, those libraries, those things only you can have. So you have an application, all runtime needs of that application can be containerized. So you have a container where your application can run. Right. Benefits versus, you can say, virtual machine. It's repeatable. It's a self-contained environment. We are going to look at that as well. Software runs in the same in different environments. So you can create a container, you can create image container, right? And that will run. You put that container in any environment, any, as in Linux, Windows, Debian, Mac environment, or some other environment which is different. It will run the same, right? For example, even for machine, for developers, laptop, test, production, all those things, right? It's also faster to launch and stop or delete, that is terminate, than the virtual machine. Now, what is Docker? Let me tell. Okay. See, Dockers and containers and AI about CI/CD pipelines, all those things. Well, we know and we can always go for that, but it's kind of, we have level 7 courses, and I'm mentioning this because I know that some of you have already done level 7 courses for some reason before doing the second year course. Anyways, what I'm saying is these things will completely make, easily make sense to people who are coming from those classes, is what I'm saying. But for our class, we need to just know what Docker is, right? A Docker is a software platform that enables us to build, test, and deploy application quickly, right? So Docker is basically an engine, right? Engine on top of which container runs. You create a container. To run that container, Docker is needed. Let's understand in this way, right? When we run containers, right? We run containers on Docker. Containers are created from a template called an image, right? As said before, a container has everything that the application or software application needs to run. All the libraries, all the runtime mitigators and basics, right? So let's try and differentiate what exactly containers and virtual machines are, right? You can see on our left, on my left hand side, obviously you're also probably, you would be right. Anyways, 3 containers on an EC2 instance. So so let's start from here, right? So you have AWS global infrastructure, where you have physical servers, physical computers, servers, and all those things. Their operating system is running, host operating system is running. Then you have hypervisor, which actually virtualize all these machines and host operating system. right? Now, then on top of that, you are running an EC2. So inside an EC2, you can have multiple containers. You can see you first deploy Docker, right? Docker engine, and then create an image, creating container, right? So inside an EC2 or a virtual machine, you can run multiple containers. So each container will have an application running and software application running. See app3, whatever app3 needs to run will have, that container will have those things. When you create image and create container, those things will have, right? Similarly, I mean, there are options as well that you can run one application across container as well. So you can have tens of containers and run single application. Again, depends on what kind of application you have. As opposed to container, if you see virtual machine, if we review virtual machines are quite a familiar concept, I guess, to all of us. So you have VM1, VM2, VM3, let's say 3 VM, right? Running on 3 different EC2 instances, right? Why? Remember, virtual machines are something which virtualize entire machine. Well, not entire machine, the machine which we want to virtualize, right? So you'll run a VM on a machine, on a single machine is what, in general we understand that, right? It will have, VM will have those software application, an application or applications, and whatever is needed to run those applications. For example, if you have created a Windows application, a chatbot, whatever, right? It will need Windows runtime 8.9, whatever. So those kind of application will there. Also will have EC2 instance guest OS. So its own OS. EC2 or virtual machine will have, EC2 is basically virtual machine, right? So, when we say it's confusing, so EC2 will have entire operating system, virtualized operating system with it, and then applications will run on a single instance EC2 or single virtual machine. Here, right, you have another virtual machine. So inside the EC2, you can run multiple containers, but one VM, right? That's the main difference here, right? So you can have, now that right? How to create an EC2, which we guys do. You have done assignments, so I hope things are clear to you. How to run, how to create an EC2, how to choose an operating system. So let's say you can, not let's say, you can actually choose Windows or operating or Linux EC2 operating system for a particular EC2, and you can install Docker, right? And create containers, run containers from there as well, right? That's obviously an option, right? But Amazon also provides similar option like Amazon Elastic Container Service, Amazon ECS, right? Amazon Elastic Container Service, or Amazon ECS, is a highly scalable, fast container management service. You can use this service to manage your containers, right? Instead of creating a EC2, installing Docker, and managing containers yourself. Now, benefits here includes orchestrates. So ECS orchestrates the running of Docker containers, right? We don't have to manage it, or Dockers and all these things are already installed, and you just put your container, you can run it. Maintains and scales the fleet of nodes that run your containers, right? Removes the complexity of standing up the infrastructure. So, creating everything to run container from scratch. So you get EC2, install many things and run container. Rather than doing that, Amazon ECS, you can simply choose Amazon ECS, configure, and use your container or run your container. The ECS is integrated with features that are familiar to, obviously, Amazon EC2 service users, which we are, right? Elastic load balancing, Amazon EC2 security groups, Amazon EBS volumes, and IAM roles. Now, if you do choose the first way, which I mentioned, like your own EC2, install Docker and configure everything yourself, run your containers, create containers, run your containers, right? You'll have to manage all these things. Load balancing, writing security groups, EBS volumes. If you choose, on the other hand, if you choose Amazon ECS, this service will do these things for you. You just have to give the configuration. You have to choose the configuration parameter and everything will be done for you, right? So when you create or when you orchestrate a container, you write something called task file, right? Where you give parameters, how many containers you are creating, where the containers should run, how many containers to run, something like that, right? So this one, using that task file, Amazon ECS will run your containers in something called ECS cluster. In that ECS cluster, Amazon will put, this ECS will put, this service will put your containers in an optimal way based on obviously need, hardware requirement for running this container, RAM, CPU, all those requirements. They will put in, for example, here you have two, in an EC2 instance, this EC2, they have two, another EC2 instance, they have put 3 containers to run, right? There's another option, Amazon ECS cluster option. You can actually choose to manage the cluster yourself, this cluster we're talking about, right? Yourself, or let another service called Amazon Fargate to maintain ECS cluster for you, right? So the key question, as I said, do you want to manage the Amazon ECS cluster that runs these containers, your containers basically? If you choose that option, then you will Amazon ECS cluster backed by EC2 provides a more granular control over infrastructure. So you choose many things. You choose all the parameters, right? Where to run, how many to run, all those things. If you say no, let ECS manage it, then is Amazon ECS cluster backed by something called AWS Fargate, right? Which if you choose this, you'll have easier to maintain and focus on your application. You focus on your application development inside the container and let Fargate manage the cluster for you. There are two options, right? Now you can see AWS manages here, right? AWS manages in any of these options. AWS manages Docker engines, one per OS in the cluster, VM guest operating system in Amazon ECS cluster, all those things we manage if you are using the Fargate. If you let Fargate manage you, you only are concentrating on applications which is running in container, right? You're writing code, whatever that application does, those things. However, if you want to manage everything yourself, that's also possible. Amazon ECS cluster backed by Amazon EC2, right? We manage everything here. Everything as in this is managed by AWS, right? Or for Fargate. However, if we do these things like Docker engines, VM guest operating system in the Amazon ECS cluster, we do everything ourselves. In other words, we manage these things. So up to us, right? Next, what is Kubernetes? You may have heard about, some of you know about this as well, particularly some of you, right? Kubernetes is an open software for container orchestration, right? It helps to deploy and manage containerized application at scale, right? The good thing about Kubernetes is same toolset can be used to run containerized applications on cloud and in your desktop or on-premises servers as well, right? It also complements Docker, right? Docker enables, as we know, Docker enables us to run multiple containers on a single host, single OS host. Now, Kubernetes orchestrates multiple Docker hosts called nodes. Yeah, so Docker will let you, you can see where was the figure. Yeah. So Docker is letting you run 3 containers on a single instance guest host, right? Now, if you use Kubernetes, you have multiple Docker IDs, for example, say, right? Multiple, this figure can run on something what they call is nodes in their terms, right? Using Kubernetes, you can automate, right? It automatically does for us container provisioning. So design, maintenance of container, like what kind of container we need, how many, how much, basically the application needs, and then container needs. Networking, also load distribution, like if your application is running multiple containers and there are multiple containers and each of them running an application, let's say, and one of the container is not able to serve, let's say the traffic is too high, then the traffic can be routed to other containers. It also helps in scaling, right? Kubernetes. Amazon Kubernetes is an open source, you can see, right? Open source software. Now, Amazon Elastic Kubernetes Service, or Amazon EKS, right, enables us to use Kubernetes on AWS cloud, right? It supports easy migration, certified Kubernetes confirmant, using confirmant. It supports easily. So if you have Kubernetes installed, on top of that, you have many Docker engine and many containers, you can easily migrate. Supports both Linux and Windows containers, right? And compatible with Kubernetes community tools, whatever tools they have, and support pub Kubernetes add-ons as well. So it's Kubernetes specific add-ons, right? We can use Amazon EKS to manage clusters of Amazon EC2 compute instances. So EC is cluster basically, right? Run containers that are orchestrated by Kubernetes on those instances, right? This Amazon Elastic Container Registry. So these containers, okay. So Windows, we all use Windows, right? We may have modified Windows registries as well. Have we done that? But these days, 11, Windows 10, we don't actually go and modify registry entries. Earlier, for a particular application, some application, you had to modify Windows registry, right? To make them run in a particular Windows operating system. These days, it's more automated, right? But have any one of you modified Windows registries or seen Windows registries, viewed, explored Windows registries? That's the question. Okay, two sides to answer. Similar concept here.
Yes.
Okay, listen. Thank you. uh, yeah, similar concept here. When you create containers, it has to be registered, right? And that registry service or container registry with Docker, with other like Azure cloud, they all provide these registry services. Similarly, Amazon also provides Elastic Container Registry. Amazon Asia is a fully managed Docker container registry that makes it easy for developers to store, manage, and deploy Docker container images. Right? So section 4 key takeaways. Now, containers can hold everything that an application needs to run. So basically, it's an image created for an application which has all the resources needed for that application to run. Now, Docker is a software platform that packages software into containers, right? Remember that a single application can also span multiple containers. We don't have to have a container and one application containerized orchestrated in it. Amazon Elastic Container Service, ECS, orchestrates the running of Docker containers. Kubernetes basically is an open software for container orchestration, right? You can have multiple Docker nodes running. If you choose to have Kubernetes, choose to use for Kubernetes running applications or containers running using Kubernetes, we have Amazon Elastic Kubernetes Service, or Amazon EKS, which enables us to run Kubernetes on AWS cloud. Amazon Elastic Container Registry, where you register the container, which will enable us to store the container, obviously, manage and deploy those containers. Any questions on containers or ECS, EKS? Let's move to introduction to Lambda or AWS Lambda. What is Lambda, right? Again, it's another service under compute services category, right? So AWS Lambda is a serverless compute service. You don't need to run server for the code you want to run, in a simple sense, right? Run code without server. We can upload our code, right? Simply to Lambda as a Lambda function, or you can write code as a Lambda function. It's an actual event triggered service, right? So AWS service, you can use AWS services, some other mobile apps or HTTP endpoints to trigger a particular event. And that once that event is triggered, something happens. What is that something? That's something you code. So like event-based, serverless computing option, Lambda is for AWS, right? So when the event is triggered by any of these event sources, right? Any of these event sources, our code runs, right? When it is triggered, and then you only pay for the compute time that we use. Only pay when the code is running, not all the time, right? The Lambda, benefits of Lambda, as in, we can write codes with multiple languages for Lambda function. It supports multiple languages like C#, Java, .NET, Python, Ruby, and probably a couple of more. We'll have to look at documentation, but these common languages they support, right? And it completely automates our administration. We don't need to, worry about many things. You simply have to configure the events, which events, but again, that is as per our need, right? What kind of things we need to do should these events occur, and we write code for that, and done. So automates administration, right? It has built-in fault tolerance, as in the resources you run, the resources you will need to run that code, or the event will trigger something, is fault tolerant. Lambda, if something fails there, Lambda can overcome those kind of failure. It supports orchestration of multiple functions. There is something called step function, right? Using this, you can write multiple or chain of functions to achieve something. If this happens, do this, and after doing that, if something else happens, then do this, something like that, right? If else ladder we can write, depending on what kind of event will be triggered and what we want to do after an event is triggered. It is pay per use pricing. It is available at pay per use pricing. Now, see, this is the Lambda function, right? Which you can upload code or write code to do something, right? It will be triggered by any event created by, right? Event published by or created by any of these Amazon services. We can actually have, other applications trigger those events as well. But generally, you can use these event sources, that is Amazon provided services, to create an event, to trigger an event. And once that is triggered, this Lambda function is run by this service called AWS Lambda, where you write code, you can run whatever, right? Depending on our application, right? It runs, and while it is running, Amazon CloudWatch is actually logging, monitoring, and have metrics as well, other uses metrics and other things, but it also logs the running status. If it fails, for what reason it failed or something, that will always help us to then debug, right? So the first thing is event sources. How events? You can see Amazon S3, Amazon DynamoDB, Amazon Simple Notification Services, and many more. API Gateway, Load Balancer. So let's say, right, load balancer. If the load is high on a particular EC2, you want 2 or 3 new EC2 which has same application to up to take the high traffic. So those kind of code you wanna write here. This will, the load balancer will say that, create an event that, okay, it is high, the let's say CPU usage is high, or the traffic is too much high, traffic is almost 80% on a particular EC2. So whatever you want to do, you want to shut down that, or you want to create new EC2 and assign those traffic to those EC2s, so that the applications on EC2 will handle the traffic, simply automating it out, right? Now it supports multiple languages, and you don't need to install anything. You simply can write your code, and hence it is called serverless architecture. AWS has, installed, obviously, those all runtime environment and everything already there. We just have to choose, right? So these are the event sources based on AWS services, which can create any event, which can trigger AWS Lambda. This AWS Lambda service will run this Lambda function and the code. The CloudWatch here logs, monitors all the execution of this Lambda function. Alternatively, as you can see, invoke a Lambda function. We can also invoke a Lambda function from Lambda console. There is a separate console for that, AWS SDK or AWS CLI. Yeah, we usually use AWS Management Console, that graphical, right, thing. From there also we can trigger. Well, from there directly you can't trigger. We have to select and we have to configure it. But from here, we can create an event. We can write a code to create an event in order for a particular Lambda function to be run by AWS Lambda, right? So Lambda function configuration. Now we have function code here in Lambda, right? So dependencies, code libraries, and all those things is managed by AWS. We don't have to worry about that, right? But while we are creating, we should select that. We will select the language we are writing that code on, and the runtime environment, particularly for .NET. You have .NET, then with .NET you have to select. It's kind of it's kind of a little bit uneasy, but yeah, with .NET 8 or 10, the version also you have to select, is what I'm saying. Otherwise, it will give you a problem when you write code. And .NET developers, I'm sure most of us have, a little bit of experience from programming 1 and programming 2. You would know what I'm saying, right? Anyways, so runtime environments all are there. We just have to select that and write code, which will, when a corresponding event is triggered, will run, right? Now here you can see there is an execution role as well. Now, if we remember, we talked about IAM creating policies, creating IAM role, right? So this role basically will define when you're creating a Lambda function, you attach a execution role to that Lambda function as well. Basically, it will define the permissions, what kind of services, what kind of resources it can access, and what kind of access it is, read only, write only, or those kind of access. You give permissions. So you define that in something called execution role. If you remember, in IAM, we had created a few policies, execution role that time. So we create and attach it to a particular event triggered AWS Lambda, right? So that's what happens. Now, a couple of scenarios, very, very simple scenarios, right? Let's say we have to stop instances based on some metrics from CloudWatch event. At night, let's say at night, we know that our traffic, no one is accessing this server, no one is accessing this EC2, which is running, for example, a production or not production, maybe development environment, right? Now we can simply say if it is 8 p.m., right? That's the event. 8 p.m. This code should execute, and this has attached a IAM role which has permission to access these EC2s, right? What we want to do, we just want to stop it. You can see here, this is an IAM role which says, this kind of code we have seen, which says, I'm just giving an example to stop these some particular EC2 instances, right? Similarly, at 5 a.m. in morning or 8 a.m., let's say 7 a.m., right? People come back to office, they want to use those things, right? You would create a 5 a.m. Event here. You just that event, let's say 7 a.m. Then the same Lambda function can triggered, or another Lambda function can triggered, which has IAM role, which has access to these EC2 instances, and they will start your EC2 instance. This is an example, right? It's a cost saving kind of example as well. If some EC2 are not required, applications running on EC2 are not required overnight period, we can always stop and we can always restart. Now we can do that manually as well, but someone has to be responsible for that, and other things, people might forget, other things, there could be anything. We can simply write using Lambda function and let AWS Lambda to do job for us. So to automate tasks. Now this is very simple example, but we can do many sophisticated tasks with this as well. Another example, or event-based Lambda function example, let's say we have to create, so users, let's say you have a web server, and images, people upload images, you went to visit some places, and your users, you said, whatever images you have, please upload decent images of, visiting sites, and your website will display that image. Right. But when user takes image, let's say your company employer user takes image, they can take in any size, any resolution, anything, right? Let's say your website displays that in a thumbnail, right? Thumbnail kind of resolution and whatever, you can define all those things. So user will simply upload that image to some S3 bucket, some space there, right? In Windows. That's how you are configured. That's within the AWS cloud, right? Source bucket. Now you have Lambda, right? So the event will be what? Someone has uploaded an image to the source bucket. Something happened, right? That's the event. Now that event will trigger Lambda. Then Lambda will look, the Lambda as in Lambda service. Lambda will look for what Lambda function is associated with that trigger. That particular trigger, upload an image, something like that, right? And it will have codes to make those images in a particular size, thumbnail size, right? Obviously, this Lambda function will have to be attached with an execution role, which says access policy, which says that this function has access to data inside this particular bucket, target bucket. Yeah. So this is an example we can do. Right? We need to worry about the quotas as well. So there are quotas to execution, right? Soft limits for execution. So if you want to have multiple Lambda functions and execute them concurrently, it's 1,000 of Lambda functions, function and layer storage. Like your code has to be stored somewhere, right? When you write code, although they are very small, they use very small space, but the limit is 75 gigabyte, right? That's a soft limit. Hard limits is maximum function memory. So function has to execute. Remember, you write code, you write in programming classes, you write code. Where does that execute actually? When you compile and when you run it, it will run in your RAM, right? Random access memory. From there, the code runs there, right? So that memory, your Lambda functions should not exceed 10,000 to 240 MB, right? Timeout should be 15 minutes. That is the hard limits, right? Deployment package size is 250 unzipped, including layers. Container image code package size is limit to 10 gig. Now this could have been updated, so it's always good to go to this link and check exact figures for these limits for Lambda. So section 5 or AWS Lambda key takeaways. This is serverless. We don't need to manage service. This is serverless computing. We don't need to manage. We can run code to do job we want. It's an event-driven computing as well. Computing service as well, AWS Lambda, right? Serverless computing enables us to build and run application and services without provisioning or managing servers. Lambda is a serverless compute service that provides built-in fault tolerance and automatic scaling as well. An event source is an AWS service, or we can create ourselves, that is developer created application that triggers a Lambda function to run. The maximum memory allocation for a single Lambda function is 10,240 MB. The maximum runtime for Lambda function is 15 minutes. Any question? Right. So the last section under compute category, compute services category, we are going to look at is AWS Elastic Beanstalk. This is an managed service AWS provides for our web application to deploy, to manage our web application, right? So AWS Elastic Beanstalk is an easy way to get web application up and running. Now, again, similar to when we talked about AWS Fargate, right? Or before other services as well. For example, databases, right? In databases, let's see. Now that you can install data, well, you can configure a EC2 to create an EC2. Launch is the particular terminology they use, AWS. So launch an EC2, configure it as per your need. You can always install any kind of applications right there and manage those applications yourself, right? One of the applications could be a database. Now you can install MySQL database or whatever database you are using in an EC2 and configure it, migrate your table from on-premises to cloud and everything. You can do that. However, Amazon also offers AWS RDS or relational database management, relational databases services, I guess, right? You can use directly that to create database rather than creating an ECW and installing that. In a similar way, right, like AWS Fargate can manage your ECS cluster, right, container services clusters. Now we have Elastic Beanstalk, which can manage web applications, right? It's a managed services that automatically handles infrastructure provisioning and configuration. So what exactly infrastructure you would be needing? So provisioning of infrastructure also managed by AWS. Infrastructure for your web application can be managed or is managed by Elastic Beanstalk if we choose to use it. It can deploy your web applications, also handle load balancing, right? Web applications, if you host web websites or web application, load balance is a factor. Automatic scaling based on pre-configured suggested parameters. It can handle automatic scaling. It will also, we using CloudWatch, it will also watch or keep monitor health of your web applications. It will help you in analysis and debugging. Also, it logs all the log parameters to the CloudWatch, right? The good thing about Elastic Beanstalk, apart from it makes your web development easier, there's no additional charge for Elastic Beanstalk, right? You only pay for the underlying resources that are used. For example, the web server, the VM, the EC2, where you have where your web server is running. If it is using any storage, or if you have, if your web application uses another another AWS services that is chargeable, those are only charged. For Beanstalk, there is no charge, right? So you can see here as figure, right? You can simply deploy your code. That is your web code. If you are building a website or any other thing, you simply can deploy your code. HTTP server, application server, language interpreter, operating system, everything is managed by Elastic Beanstalk, right? So we don't have to worry about that. It supports the coding language, it supports, right? For common platforms like Java, .NET, PHP, Node, JS, Python, Ruby, Go, and Docker as well. The container, engine we saw. So Docker engine will containerize an application that is, web application you are developing or you have developed. So that container can also be handled by AWS Beanstalk, Elastic Beanstalk, right? We simply upload our code. Elastic Beanstalk automatically handles the deployment, of web application into that web server, and web server, different types of web servers are also supported. I'm sure in one of the lab, you guys, installed a web server called Apache in the Linux server, which you configured in one of the labs. And there are other web server like NGI, NX, NGX. This is Passenger. I've never used it. Puma and Microsoft Internet Services, Information Service. Sorry, that is IS. These are different web servers, right? Benefits of Elastic Beanstalk, it's fast and simple to start using. You simply upload your code. Everything else is handled by deployment, load scaling, automatic scaling, that is load balancing. Everything is handled by Elastic Beanstalk, right? It helps developer to be productive. As you see, developer should only be now worried about the code, the application which he or she is developing, the team is developing. So only coding and other things like configuring firewall, configuring load balancing, for example, right? Those things, deploy server issues, logging, other issues, everything is handled by Elastic Beanstalk. So developer productivity should, or increases or must increase, right? It's difficult to outgrow because of the settings there, right? Using an automatic balancing which is fixed, or Elastic, it automatically scales. So you'll not have a problem that one of the server is getting a lot of traffic. Although you can set parameters based on, let's say, CPU parameters, right? CPU utilization parameter from CloudWatch, that if this web server running on a particular EC2, if CPU usage reaches 80% or 85%, then spin up few more web servers and redirect this traffic, all those things, right? So if you use Beanstalk, it's very difficult to if it's unlikely that your application will go down because of load balancing or not scaling or something like that, right? You also have complete control over your resources, as in you can choose your EC2 memory, all those things by yourself. While using Elastic Beanstalk, which is again a free service, and you can actually, if you are not using those resources, you can release those resources as well, delete, terminate as well, or you can grow, add resources, all those things. Elastic Beanstalk allows us to do using a fairly simple configuration method. Right. So we have a small, very small activity, which is again on lab, and we are going to do that tomorrow. We are going to do that, right? So key takeaways: Elastic Beanstalk enhances developer productivity because you are only worried about code, basically, right? Coding and developing that application, how to make that better, all those things. Everything else is simplified and handled by Beanstalk, right? Obviously, will reduce management complexity. Like, for example, even you don't have to worry about security aspect because it's done by Beanstalk, the firewalls and all those things configured by Beanstalk. Elastic Beanstalk supports the following languages, as you can see in the slide: Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker. The good thing is it's free. There's no charge for Elastic Beanstalk. Pay only for the AWS resources that your application is actually using. Right. So to start with, we looked at different compute services, right? So in this module, we took a kind of overview of different AWS compute services, which is available in the cloud. Why to use EC2 or Amazon how to use, why and how to use Amazon Elastic Compute Cloud, EC2. We also looked at different functionality, how we launch, what those parameters while we are launching mean, how to configure a security group or other things. Also, we looked at for EC2 using Amazon EC2 console, that is a part of the management console, Amazon AWS management console. We also doing the lab, how to we saw how to perform basic functions in EC2 to build a virtual computing environment, right? Today, we talked about how to optimize cost of EC2. There are 4 pillars: right size, right? Optimal storage, optimal right size, optimal storage, and I forgot some. Oops, sorry. Yeah. Optimal pricing model increases elasticity and optimize storage choices. So based on our need, we should always look for the recommendation is to have an individual or a team of people looking after optimizations. So that's EC2 cost optimization. We also tried to understand what Elastic Beanstalk is. Elastic Beanstalk is, which is basically managed service provided by AWS to manage our web applications, right? We don't need to install, configure, manage many things. It does that for us. We just need to concentrate on our web code, the application code. We also saw what AWS Lambda is, right? It's basically serverless event-driven computing service provided by AWS, where we can write code, we can upload, write code, which does our desired things should an event occur. So we relate that to an event rather than to a server. If an event occurs, we want to do something, we can do that, right? We also briefly looked at containerized application. What is container? What is Docker? What is Kubernetes? Very briefly, we mentioned those services, and we looked at ECS, that is Elastic Container Service, and EKS, Elastic Kubernetes Services. Those are for managing, deploying containers, right? In a cluster of managed servers provided by AWS. So don't forget to complete your knowledge check. Here is a question to wrap up this module. Which AWS service helps developers quickly deploy resources which can make use of different languages such as .NET or Java? Out of these 4, which AWS service helps developers quickly deploy resources which can make use of different programming languages such as .NET and Java? Now, please answer. You can tell me the answer or you can type. I would like to see the chat number of chat go really high, maybe up to 22, 23, maybe 21. I can see only 4 there answers. whatever answers, right? It could be right or wrong, doesn't matter. Okay, I see a few answers, which is basically C, right? We just looked at the AWS Elastic Beanstalk. Basically, it's to manage web applications, but you see the question never mentioned web application here, right? So we just looked at AWS Lambda, which also kind of supports similar language like .NET, Java, and many other languages, right? So if it had AWS Lambda, we could have, they should have mentioned web applications or serverless computing, those kind of keyword. It's not there. So that's the only option we have. Yes, yeah, because if there was AWS Lambda, then there could be some keyword which will indicate that the answer will be Lambda. It's a very generic question, and there is only one service that does that. Okay, um, that's the answer. Yes, yeah, yeah. I mean, anyone can, Chris. What you were confused, I would be confused as well. But I would then read question, and it never mentions, anything which can relate to AWS Lambda first. And to start with, Lambda is not an option. But this statement is also true for AWS Lambda, isn't it? So the keyword in questions are developers quickly deploy resources and different programming languages, and that would mean that AWS Elastic Beanstalk, where we write or deploy, we write our code and deploy, and everything is managed by this self-managed service called AWS service, right? These are additional resources to refer for compute module. This module. And this is the end of the class. We'll do a Q&A